It is my pleasure to introduce Professor Sergio Vieira. Sergio was trained in the south of Brazil in Rio Grande do Sul and Porto Alegre. He received the undergraduate, well, there it is, coming back. He received his undergraduate as well as his master's there. He was trained in agronomy and then trained in animal science. After he finished his master's, he did something very unique. He went to Cedia, Concordia, where he formulated feed both for broilers and for turkeys at the complex of Chapicoa. He did that for 3 years. Then he went back to Porto Alegre to be a professor at Rio Grande do Sul. During this time, as professorship, he came back to the U.S. twice. He received a PhD with Professor Ed Moran in the area of nutrition on carcass quality, and then he came back with Professor Rosalina Angel, which is here with us today at the University of Maryland, where he had received a postdoc with her. So it's a pleasure for this presentation because he will give us a very practical application of least cost feed formulation, what we see as nutrients, and what we don't see and how we should evaluate those. Professor Vieira, the floor is yours. Thank you.
Good morning. It's 30 minutes, right? So I was thinking yesterday on how I was going to get started today, and I remember one very unique thing that happened to me back 25 years ago. I was actually going to attend a meeting where I live, and Dr. Miles was supposed to give a speech there. A lot of people. I don't know if all you remember him. He's an important professor in the history of animal science from Florida. So I go into the elevator, he's coming out. So I grab him, and I get like 30 seconds to ask him 5 questions. And he told me one thing that's very important, that keep coming back to my mind. It says, don't forget the concepts. Concepts are very important. So what I'm going to try to do today is talk about some concepts. I have some struggling moments on trying to understand exactly what you thought. But at the end I say, okay, I'm going to give whatever I want. So I decided to talk about some concepts on what's actually important to see and what we don't see. So you make a decision on what's the digestible solution that you want. Okay, so when we feed formulate, you basically work with databases, and thanks Gonzalo. Thanks a lot. Any table is good, any table is bad, so the worst thing is not having a table, right? So it's a comparison you showed is very, very interesting. We'll talk about that later. So we, at the beginning, if you look back 50, 60, 70 years ago, go to it's being written in standing in the libraries, you see that we went from total everything to digestible some things, and now we're talking about digestible phosphorus, for example, trying to move to digestible calcium, and struggling to understand what's the impact of one to the other. So what we actually not been observing throughout the time is when you print out a feed formulation from a solution of any software that works with that is what we don't see. So, and the whole enzyme business is actually based on what we don't see. So that's interesting. So, and how big is that? First question, right? How large is this part that we don't see? And then, what is made of? So, complex enzymes are good for solutions when you have a mix of everything, but sometimes they don't really address with the effectivity that we want some parts that are important in some other feed formulation. So I call that indigestible. That was another struggle because I really couldn't make a conclusion on if that word is written with an U or with an I at the beginning. So I decided to leave that with an U. So it seems that indigestible is something that's either totally or incompletely digested. So why why we don't have the complete digestion of a feed. And how come we can get back this part partially or totally? Or is that good if you can actually digest everything? Or should we leave part of that undigested? Should we actually move to something in the near future, or no, we're actually looking at transforming it to something that's more beneficial? So birds lack endogenous enzymes. Or there's cage effect. Some people call that cage effect when it's isolated by something that's not digested. Gut integrity, very important. I'm going to talk about that at the end of my presentation today. Microbiota has everything to do with gut health, but also is completely affected by the diet. Passage rate, Rosalina, can you help me with that? Passage rate is very important. If it moves too fast or too slow, it's totally different digestible. So, and then what's the benefits of some of the undigestible parts that we actually not looking at? So, plant origin, animal origin. I know you guys in Europe do not use animal proteins, but they are very widely used around the world. So it's a completely different story, because animal byproducts are affected by the tissues that make it up, but very well affected also by the systems that process it. So we see that in the pet food industry. So this is a plant cell, animal cell. Main difference, cell wall. Secondary difference, huge water vacuoles that occur in the plant wall, plant cell, but not that big in the animal cell. So that's the main difference. The whole thing resides on what's in the cell wall and what's in between two adjacent cell walls. Plant ingredients. Differences are important around the world. In America, from North America to South America, main ingredients are corn and soy. Soy is a very different story, right? Soy can be not well toasted, not completely processed, or differences in huge differences in total protein. Wheat, we use wheat in the south of Brazil, and sometimes in Argentina, but the wheat that goes to animal feed in those places is not as good as the wheat that you guys use in Europe. So it's a totally different story in terms of digestibility. So if you look at the well-developed grain, you see the blue stains actually separating the cells in this cutting here, and this is totally different here. So this is, in between, we see what? Less cell contents, much more undigestibles, much more viscous capacity, right? So in between those two types of ingredients, there's huge differences in potential for adding enzymes and getting more from this ingredient compared to that one. What's actually the main parts that are undigestible? So what are those components that actually we're looking at mainly? We call them generically, sometimes we call them hemicellulose. That's an idea that's separating groups that are very different, but they're mainly here, right? But in between them, there's so many different molecular structures. And for an enzyme to be efficient, it has to actually target those bonds that are in between those monomers. So if we call xylan something that's generic, we may be really making big mistakes when we're actually adding different xylanases. So if you get access to cell content, for example, by looking at this model on soybean that's toasted and extruded, taking reference from different investigators, we see that from toasting to extrusion, there's a very important improvement in what's inside of the cell wall. So that's because mainly when the plant cell is actually destroyed, it allows much more comprehensive access to what's inside. Okay? Same thing with rice bran. As you can see here, you go from raw to toasted to extruded, you get a much more important access to what's inside. So what I'm saying is that whatever is the technology you're using to access what's inside the cell wall, you're going to be more efficient, not only by digesting the actual cell wall, but what's actually being separated and isolated by it. Okay? So what's then digestible? So that's the fraction that's recovered in the feces. So it's the opposite on what we learn in school when we say digestibility. So the coefficient of digestibility is the percentage of what's actually not showing in the excreta. So the undigestible, it's that minus 100. And we have been actually using a lot of different concepts and suppositions to separate those from apparent to true in very different sites of collections. You know, from SIBO to alleles, nitrogen-free, whatever. So this is a very different, those are very different numbers in the literature. You can't compare them. 10 years comparison between this type of studies, it's a huge difference. Methodologies changed in the last 10, 15 years and are providing us totally different numbers. Okay? So you gotta take a look at that. So when you actually estimated what's left from crude protein, I know that crude protein is not a very good, concept because it's basically nitrogen times 625, and that's a huge variation between the total nitrogen in proteins around the feed ingredients. But if you look at that as a reference, and then you look at that, what's undigestible, huge opportunities. A lot of people ask, what's the importance of adding protease? Because digestibility, for example, in soy is so high, it's 90. Well, it's a ton of soy, that means 100. It's 100 multiplied by thousands of feeds per month, ends up being very important. So protease became very important in the last years, not only because of these fractions here that's left, but also because there's been huge improvements in those additives. Okay? And what about differences in digestibility of amino acids? I'm taking tables from different authors just to show you my points in here. See, huge difference in numbers between ingredients, but also between amino acids within each ingredient. And that's apparent. If you go to standardize, it's totally different numbers. So how come I'm going to feed formulate if I'm taking table A, table B, and table C, putting it together to build my requirements, and then press the button and get my final solution? Can't do that. Just can't do that. It's wrong. It's going to end up with a big wall of defense at the end when you get the final feed formula. So it's been shown that oligosaccharides are very important in soy. Soybeans are basically the one source of protein in the world. You remove soybeans, the world has no protein, basically. 90% or close to that, that's available. And that's ended up in our plates when the feed that we eat as protein comes from soy. So anything that we get back from soy is important. energy is very limiting for poultry. Difference between energy that's available for swine and poultry is 1,000 kcal. It's huge. Okay, big part of that comes from these small molecules that cannot be digested and actually harm the intestines because they are huge producers of hydrogen. By being producers of hydrogen, they create anaerobics. By producing lower pressure of oxygen in the upper tract, they totally change the microbiota. Sometimes animals become sick or respond with malabsorption to that. So it's been shown that when you remove that, big difference in digestibility. Okay? Okay, potential for energy. So that's the ratio between gross and energy and metabolic energy. Huge opportunities for poultry. Bigger opportunities in poultry than with swine. It ranges from 60 to 85%, or even more than that. If you try to destroy totally the cell wall, we're looking at totally removing the defenses of what's in the cell wall and in those viscous celluloses that are in between the cell walls. We actually are looking at having mainly those two pentoses. Pentoses have a totally different cycle from absorption to metabolization to excretion and to the creation of a different pattern of osmolarity in the gut. So this study for me is very important because it shows when you have an excess of pentoses in the gut, we actually have reduction in energy. So when we're actually adding a pro-digestible solution by adding xylanases or arabinosidases, we're not actually looking at getting energy from those guys. We're actually looking for destroying the wall that they are actually making part of. So we can have access to whatever is separated by that. The time. Okay, other things that are important. Drying corn is a big issue in corn production sites. In Brazil, we have 3 different seasons to harvest corn. Sometimes we end up harvesting and have to dry that quickly so we can get to the next rain season. So it's been shown that when we actually dry corn too quickly, we have reduced performance in the field. The better explanation I get from that is shown here by this study from 1973. That's actually better expressed in this graph. We can see that soluble protein in corn is importantly reduced when you actually dry corn with a temperature that's too high. So that affects totally the utilization of that feed ingredient that makes up from 60 to 70, sometimes 75% of our feeds, especially if it's an all-veg feed. So hydration is a requisite, is a requirement for digestion, okay? But by only running a proximal analysis, so we don't get a response on what actually can be utilized from corn. We have to understand at minimum how this corn grew, right? It had a complete development, but also we have to understand if that corn was adequately dried and adequately stored. I'm not even talking about mycotoxins, okay? So to show you a representative difference between Brazilian corn, we see differences that can range from 3,045 to 3,400 kcals. It's a big sample provided by a colleague from experimental station in the south of Brazil. And you see that this variation is around, so you go to a table, get like 3350. We formulate, we don't get the response that we're looking at. That might be due to differences in corn quality. But also, we don't know exactly what is corn made of, mainly. So if we actually feed normal corn to oxycorn, and a lot of corns that are in between, these corns have differences in terms of the capacity of being hydrated and then digested. So in this study here, we see that first, big differences when we feed chicks and roosters, right? But also important difference when we actually go from a corn that has less amylopectin to a corn that has more amylopectin. Who knows exactly what's the proportion that amylose and amylopectin in our corn? That's an important difference that affects energy. I'm going to ask you to try to look at this table. I'm going to move specifically on what I want. This is 5 diets with different feed ingredients, trying to demonstrate what we get when we feed formulate. For example, ingredients in here, and then all of this is the indigestibles, right? It's very difficult to build a table like that because the tables that are around the world only show what is digestible and what's available. But if you look at what's in the bottom of the table, from insoluble fiber to soluble fiber, and then we actually get the soluble fiber and look at pectin, xylogalacturans, reminogalacturans, oligosaccharides, then you can actually have a better image on what would be the prodigestible solutions that we're looking at from different feeds to different feeds, right? Not sure if I got my point here, but that would be a very excellent, very good exercise for any practical nutritionist. And guys like Gonzalo could help you with that because he's got a lot of data that's not being published yet on that. So growth is affected also by other things besides digestion. It's affected by age. If you look at the efficiency of deposition from a chick to a fully developed broiler, what is retained is 1/4. It's 1/4. So we're actually losing 75% of what has been digested and being absorbed. And this is going to be the end of my talk in the next few minutes. I'm going to try to move to a new concept when we actually have less opportunities of using traditional additives like antibiotics to modulate what is actually causing these losses, right? Part of it is basically maintenance. Bigger bird, higher maintenance requirements, right? Part of that is basically the quality of the protein. From 21 to 25, increasing lysine improves retention. Okay? And this is actually sometimes bigger than any difference in enzymes. We're missing that. We don't look at that. So what's being in the gut that's actually affecting that? Any mucosa is actually, in a normal bird, is colonized by microbes, right? and basically have no idea. We talk about good microbes, bad microbes, but that's it. Most of the times we cannot move forward from there. Okay? So diet basically shapes the composition and activity of the gut population, and any bacterial overgrowth releases endotoxins. The most important endotoxin that affects us as humans, but also the animals, is LPS. LPS is lipopolysaccharide. It's what in this outside membrane of gram-negative bacteria. And the gut is a big, big reservoir of that. Even more if the animals eat animal byproducts. Okay? But any gut is colonized by that. And studies with humans are showing us that this LPS can actually be absorbed, and it provokes chronic inflammation. Inflammation, as the end process of inflammation is degradation of tissue that has been built. And that's very important. We're not even looking at that. And that's because sometimes we actually kill this. For a long time, we've been killing this bacteria, reducing the total amount of bacteria that's in there because we've been using antibiotics for a long time. We're still using that sporadically, but as a chronic usage, as a growth promoter, we miss that. We cannot do that anymore. So diet as well as ingestion of life beneficial bacteria may also assist in maintaining gut health. I have no doubt that these probiotics or life beneficial bacteria will have a very, very enlightening next 10 years. Okay? So intestines, let me move here, are colonized by bacteria, modified by diet. Pectin has been shown for a long time as one of the fractions of the diets that are very harmful. In this study from 1973, the authors added penicillin, and they got a tremendous improvement in performance when the diets got an increase in pectins. The question is, should we actually destroy totally the pectin? On the other side is studies showing that when we actually destroy pectin to the actual monomers of galacturonic acid, we actually induce reduction in appetite. So what's the solution for pectin? In this study here, big differences when you add pectin in animals that are in normal setting or in those that are in a germ-free setting. No effect in germ-free setting. So the problem is actually being caused by the bacteria that's being grown with the addition of pectin. So we got to modulate the bacteria or partially destroy the pectin or having both things together. So these endotoxins disrupt intestinal integrity and lead to inflammation. So LPS, we have to learn from human science. They've been actually showing that LPS can actually pass through the cell lining. Not huge concentrations as we see in the lumen of the gut, but small concentrations, especially when the animals are fed high-fat diets. You see that? High-fat diets cause chronic disease, chronic inflammation. So that's gram-negative bacteria. So that's LPS. That's the external membrane. So high degree of inflammation of individuals with metabolic diseases could be a consequence of the excessive production of mediators that are stimulated by LPS. LPS can be absorbed and circulates in low concentrations in humans. That has been shown. So how come this actually passes through the circulatory system of the animals? Let me move to this next one. A possibility is that the space between two enterocytes being damaged, and that damage can actually be caused by bacteria, overgrowth of bacteria. Regardless of the type of bacteria, they can actually disrupt the tight junctions. These tight junctions, they actually leak, and they allow, as a defense mechanism, they leak, but they actually allow an influx of what's in the lumen. High-fat diets, solubilizing LPS, can actually increase circulation of this bacteria. So what's the prodigestible solution here? Zonulin is a protein that actually modulates this disruption. Zonulin can be modulated. So I see that there is a future in modulating the production of zonulin. So what's the best way of doing that? The right diet, the right bacteria in the gut. So this is an example of that. A lot of proteins that's being disrupted. So my final remarks would be, is it beneficial to totally degrade what's in the indigestible fraction of our diets? It's still struggling to use ME as a good indicator of energy utilization by broilers, differently from swine. Very huge variations between site to site, from investigator to investigator. So what's the interaction between undigestible and inflammation? That's an open site. There's nothing published in Poultry on that. The human nutritionists are really looking at that carefully. And modulating inflammation is going to be very politically adequate. A well-seen way from the customer side, from the customer side. They will be well seen as a way of modulating it without using antibiotics, by using politically rightly adequate methodologies. I thank you, Pierre. I thank you, Adsil. I thank you, the Brazilian team of Adsil, that allowed me to be here. And if there's time, I can answer questions. Otherwise, I will sit.
Let's thank Professor Sergio Vieira.